Hey everybody, welcome to Brain Over Belly. I am David Brown from Everest Surgical Institute and Idaho BMI. This podcast is all about solving the puzzle of obesity and the other diseases that are overwhelming our society and shortening our lives. It is high time for a new approach and better understanding of what is really going on. What we are witnessing isn't normal. I want to pivot in a new direction. Let's get started now by putting the pieces of the puzzle together. Thank you for joining us. Hey everybody, this is Brain Over Belly. I'm David Brown. Welcome to the podcast. We have with us again Chanel Drucker, our dietitian.
Hello, everybody.
Thanks for joining me today. Today's topic, I think, is incredibly important. It has significant implications for aging, for obesity, for diabetes, and that is exercise, but specifically why you should exercise fasting.
Yes, I think a good way to kind of intro this is we can call ourselves the MythBusters. So,
fair enough.
The most common thing we hear is, okay, before exercise, we need to eat food. Specifically, carbohydrates, I think, have been the most common thing we're told to eat beforehand to give us energy. And then right after exercise, you got to eat some form of carbs and protein to build muscle, sustain muscle. And I think that's been taught regularly for a while now. I think we're here to debunk that.
Okay, good. That's a good start. I've been exercising 6 days a week for, 17 years or something like that. And I cannot tell you how many trainers I've talked with and met and just talked about these topics with. And I would agree that is an incredibly consistent concept, idea among trainers and people generally. Is that look, if you're going to exercise, you got to be consuming energy and protein either before or after or during exercise.
Yeah, and I think a lot of times they even tell you, oh, if you want to lift the heavy weights, you got to make sure you have that fuel. I know personally, I used to never be a breakfast person. I went to college. I worked with this personal trainer. They're telling me, oh, you have to eat before exercise. So I trained myself to do that. And then you learn, oh, maybe that's not the best route to go. And then you have to untrain yourself a little bit too. I kind of got in this weird habit and then I had to break it again. So personally, I felt, I know we're going to go into a scientific kind of level, but I have noticed myself that my exercise has improved while training fasted. I know we talked about it a little bit once.
That's blasphemy.
I know. One time, I think we did a 3-day fast here segue, and I had the fastest mile time on this day 2. And I was like, yes. I was like, this is crazy.
I had a PR in pull-ups 3 days into a fast.
Yeah.
Within the last year.
Nobody would believe it.
So I think there's 2 parts of that.
Yes.
You mentioned fuel. I think that's part of the myth is that, look, you got to give your body fuel to go out and do all that activity, whether it's cardio, weightlifting. I think especially with weightlifting, that's the perception. You got to have fuel. And the second thing is protein. Hey, look, you're going to build muscle. You got to give your body the protein and the amino acids in order to build that muscle. Fair enough?
Fair.
Okay. So what I would argue is it's totally wrong.
I would agree.
We want to exercise while we're fasting. And I would even say that if we follow the myth and we do that, we're consuming fuel, protein, either before, during, or after, right after exercising, we are forfeiting some of the major benefits of exercise. So I think it might be helpful to back up and ask ourselves the question, what's the goal? Why are we exercising?
Yeah.
A lot of really smart people would tell you that if there's one behavior human beings can pursue and do consistently to extend their life, it's exercise. And I think that's a fair assessment. I think that is at the core of why we exercise, from biochemistry and mechanics and a lot of reasons. So we've talked about longevity on this podcast before, and I would suggest there are two primary elements of the aging process. One of them, probably the most important one, is incrementally losing the capacity to pull fuel out of storage. We're all very good at storing fuel, right?
Yes.
We got a lot of problems in health in America today. That is one way that we do not fail, and that is storing energy.
Yeah. And that's a good way to kind of side note that is exercising is not just about burning excess calories. We're kind of focusing now on the longevity, your health, all of that. The primary goal of exercise is not just to burn calories.
Yeah, and that's a good point. Mm-hmm. That's another myth, is that we want to exercise because we're going to burn calories. It's a really inefficient way of burning calories. You know how far or how much you'd have to run in order to burn off the calories in whatever, a Big Mac?
Right. You can't compare
12,
it.
14 hours. I mean, that's not why we exercise, is to burn calories. So aging, back to that first driver of aging, and that is over time, having a progressive loss of the ability to pull fat out of storage and to burn it in a healthy way. Now, if we're following traditional dietary thinking and we're eating 3 meals a day or 4 to 6 small meals a day, we're eating consistently. We never really have to pull fat out of storage to burn it. And so over time, we lose that ability. And it's in that progressive loss of the capacity to pull fuel from storage and to burn it in a healthy way. It's in that context, or it's in that loss, that insulin resistance and inflammation arise.
If you don't use it, you lose it. You lose that ability.
Right. We have the genes for all the machinery, all the enzymes, proteins, in order to pull fat, those fatty acids, triglycerides, from fat cells, adipocytes. But if we never use it, we progressively lose the capacity.
And exercise on top of, so we have that ability even without exercise, right? But it's just more talking about one of the key components of exercise is that it helps you pull from that stored fat. It's kind of like a boost.
Right. And there's been several studies, one I can think of, very elegant, done in the last couple of years, that looked at this very question. Young males who lift weights consistently, you break them up into 2 groups, and it's a crossover study, so each individual gets a chance at 2 sort of approaches. One is you eat right before working out, or right after, or you do exercise fasting. And it was incredibly clear that fat oxidation, beta oxidation, the burning of fat, is much higher when a person is exercising while they're fasting.
Yes, that's where we get that increased fat burning, right? That's what people refer to it.
Right. Now, we just said we're not exercising to burn
fat, but
calories.
Right.
But it's training our bodies to do that. It's not necessarily the amount of fat that we're burning while we're exercising, but we are exercising the ability to do that, or priming the pump sort of fat burning.
Makes sense.
Okay. So, and the same thing with glycogen, which is really the storage form of glucose. Mm-hmm. Diabetics, they have high blood glucose and problems in that system also. So really, exercise primes our bodies to pull fuel from storage and to burn it appropriately.
Well, going back to that study, because I know we just talked about that earlier this week, can you touch a little bit on what happened to the group that fasted versus the group that did not fast? Because they kind of compared the two with muscle and strength.
Okay, different study, I believe.
Oh, are you talking about a different one?
Well, a different study, but it's a great point.
Okay.
Okay, a great study out of Germany. Is it Germany? Yeah. They took young males who had a background of lifting weights. These are young males, 20s and 30s, who very frequently lifted weights and had been doing for a lot of time, a lot of years. And they broke them up into two groups. One of the groups just ate their normal way, 3 meals a day or whatever it was. The other group, they taught them intermittent fasting and had them fast regularly, 1 meal a day or some form of fasting. And they followed these two groups of young males for a year. And what they found is that generally, the group of weightlifters who fasted regularly, they lost a little bit of muscle mass, okay? Lean body mass.
Nobody panic.
Right. There's a reason for that. It's not necessarily losing functional muscle. What they found is that muscle strength, after a year of fasting increased. The group that didn't fast regularly, there were no gains. Love that word. There were no increases in muscle strength. It really contradicts traditional thinking. Fasting increases muscle strength.
I think that's just a good thing to point out too, as we talk about our personal experiences with exercising fasted, that there are studies that prove the benefits of it. So it's in writing that these people increased strength over time by fasted exercise versus a group that did not.
Yeah, pretty good studies, design studies. So for some reason and in some way, regular fasting in some form actually increases the efficiency or strength of muscle.
It's better quality.
Exactly. So that's a huge topic, and I'm fascinated by it, very interested in it, and we can talk more about that. So also worth noting this idea that around working out, you got to be consuming carbs.
Right.
So you got the fuel and you need protein. There's an internal source of carbohydrates, right?
Correct.
There's several of them. There's no such thing as an essential carbohydrate. That's maybe overused statement, but it's true. We do not require any carbohydrates in our diet. When I was in college, it was the belief, very strongly held belief, even dogma, that your body can take carbohydrates and convert it to fat. It's been known for a long time. It's always a bummer because with that was the concept that your body cannot convert fat to carbohydrates. Always was sort of a bummer. Like, dang it, if you want to lose fat, you got to cut out carbohydrates. Everybody loves carbs. But we know now that's not true. There's at least 22 pathways in which your body can convert fat, meaning triglycerides, into carbohydrates. So you don't have to eat any carbohydrates. You have an internal source.
Correct. I just want to reiterate that too, because I hear that a lot, that people come in and they say, I need the carbohydrates for my brain to function. So repeating that your body can turn its fat into enough glucose for your brain to function properly. You don't need to get it from a dietary source. I just want to make that so clear.
Right. And the brain doesn't use exclusively glucose for fuel. It can use ketones and so, which come from fat. So, and interesting in people who are conditioned athletes, if you take someone who's keto or they never eat carbs and they do endurance, athletic events. I think this has been done by Volek and Finney and some other great scientists, but they looked at the glycogen storage. Again, glycogen is the storage form of glucose, sugar. And what they found is in endurance athletes, highly conditioned athletes who are low carb / keto, their glycogen stores were normal. So the classic culture of working out, especially in endurance, is a carb load. You got to load up on carbs before you do that marathon. And it's just wrong. You don't have to do that. You have an internal source of carbohydrates and a means of replenishing glycogen from burning fat. And that's surprising to a lot of people, but it's elegant. The body is absolutely astonishing in how sophisticated it is.
It's smart. It kind of makes me think of this picture. There's a woman in a 2006 Ironman, I think it was. She had to crawl her way to the finish line because she ran out of glycogen or, whatever. But you also saw another athlete who was low carb or keto, and they were able to finish that race without so much fuel stations and all, right? Because in a lot of the dogma is you got to eat every 20, 30 minutes when it comes to those races. And I think that's someone that is not fat adapted.
Right. And so the classic scene is on this marathon, mile 15 or whatever, everybody's grabbing these sugar packs, these gel sugar packs. They got to replenish their energy because they're getting low. And they need the calories to burn so that they can complete the race. Well, if a person is, you mentioned fat adapted. In other words, their bodies are conditioned and adapted to burning fat as the primary fuel. That challenge largely goes away because we all have fat available to us.
It's constant. It's a constant pulling. It's there's never a peak in a valley.
And I've heard it said that when an athlete or a person becomes fat adapted, that event, whether it's a marathon or swimming or whatever, it goes from a limiting factor of energetics to mechanics. In other words, the athlete who is adapted to burning fat for fuel no longer is their limiting factor energetics having fuel. It's mechanical. In other words, joints, bones, etc., which is really fascinating.
It also kind of goes back to the topic of aging as well, and how weightlifting, exercising regularly is great for your bone health, which also declines over time as we age.
Yep.
Bringing it back to that topic of aging.
Yes. Before we go there.
Yes.
An important point. We're talking about fat adaptation. In other words, a person's progressive ability to pull fat from storage and burn it in a healthy way. Exercise facilitates that adaptation. So does fasting. Again, these are things where there may be an increased requirement for fuel, but we're not providing it through the diet. Exercise, fasting really have the same effect. Interesting, on muscle and on strengthening or increasing the body's capacity to pull fuel from storage. Exercise, intense exercise, and fasting, very similar in what they're doing in the body. Just really pretty cool. But in addition to adapting to burning fat as our primary fuel, muscle has the capacity to adapt in a astonishing way. In other words, 15 years ago, I was consuming some source of protein every 2 hours because I was worried about muscle wasting. Mm-hmm. And now it's very different for me. I eat dinner usually 5 or 6 p.m. And then I don't eat until the next day, usually 12:30. What is that, 18 hours or something? Mm-hmm. But I exercise. I do weightlifting pretty early in the morning, either 4 o'clock or 5 o'clock. And so really, I'm working out fairly intensely, pretty much in the middle of that.
In the middle of the fast.
18-hour fast. Mm-hmm. And because I've been doing that 6 days a week for, 12 years or something, there's never a question of energy or bonking or struggling with that. So the point is that muscle, and I'm not just talking about me, but the science shows that muscle also adapts with repeat stress, exertion, and fasting. Both of those two behaviors increase the body's ability to preserve muscle, functional muscle that translates into strength.
You can train it.
Right. So you have these two parallel things happening. Exercising and fasting, you increase the body's ability to pull fat from storage and to burn it in a healthy way, and your body gets better at preserving muscle. And studies have shown that, if you take someone who hasn't been exercising, they just haven't been doing it, and you start them out lifting weights, for the first few months, there is a time window after lifting weights where they probably should take in some source of protein in order to have muscle synthesis, muscle building. But as a person is consistent at that, say they've been doing it for at least 6 months, that window of time expands and actually disappears. So a person who's been lifting weights I don't know, 3, 4, 5, 6 times a week for 6 months or a year. They don't have to eat any protein afterwards. It can be the next day. It can be, so that window of time goes away. So it's just an elegant way the body, the muscle specifically, adapts to these conditions. So, and in all that, as we build the body's ability to pull fat from storage, as well as preserve muscle, inherent in those abilities is reduction of inflammation and insulin resistance. Okay, so aging. These things are at the core of aging. I mentioned the first element or pillar of aging from my perspective, and that is the progressive loss of the ability to pull fat from storage, fuel from storage, and burn it in a healthy way. Second pillar of aging or driver of aging is the progressive loss of the ability to recover from a stress. And exercise and fasting are types of stress. You're practicing these stresses and giving the body practice and recovering. That's really why we exercise. It's to cause some degree of trauma in the body.
Right. We're literally damaging muscle so it rebuilds.
Right.
Bigger and better.
And as the body recovers from exercise, it has greater and greater ability to recover. So anyway, aging, fundamental to the process of aging is losing that capacity to recover. How does healthy muscle relate to aging, Chanel?
Well, as most of us age, we lose muscle mass over time. You can see this a lot. I think women over the age of 40 tend to lose more muscle mass at an exponential rate, but just people in general.
Yeah, males and females.
Yeah.
The typical saying is that about age 40, people start losing muscle mass. And it's pretty universal, close to it at least. And it's thought, and studies demonstrate this, that it's correlated with premature mortality. Less muscle a person has, the more likely they are to die prematurely.
And I also think there's like this stigma that, once I hit this number, my muscle mass is vanishing. And it's not the number that's doing that. It's a lot of other lifestyle.
So I sort of want to tear that apart.
Good.
Aging, I think in all this, we're conflating some fundamental things. In other words, yes, as people age, they generally lose muscle mass, but there's other stuff going on that I think can explain that loss of muscle that we do have some control over. So in other words, I do not think it's inevitable that we lose muscle as we age. So insulin resistance worsens with age. Okay? Generally, and it's, again, this is a universal thing. If you look at the prevalence of diabetes in 20-year-olds, 30, 40, 50, all the way up, there's a steady increase in the rate of diabetes. And that goes to 75. And this is very much related because there are two parts of muscle mass, or two elements. One is, how much are you generating or synthesizing muscle?
Right.
Versus breaking it down. Those two things are always going on. And so how much muscle mass depends on these two things. How much muscle do we make? How much do we break the muscle down? Well, insulin resistance decreases our rate of muscle synthesis and increases the rate of muscle breakdown. Okay?
Yep, I'm following you.
So could it be that, people lose muscle mass as they age, not just because it's inevitable, but simmering under all of it is some degree of insulin resistance. And so they're making less muscle and they're breaking down more muscle.
And then over time, it worsens and worsens. And I think it's a snowball effect, essentially.
Yeah. And muscle is a metabolic organ. It's an endocrine organ. So sophisticated and marvelous. You can also look at measures of oxidative stress, also known to be fundamental to aging. Over time, we age, oxidative stress goes up. And of course, they're related. Muscle mass goes down, oxidative stress goes up. insulin resistance
Goes up.
increases. Okay. Dietitian, Chanel, what happens to the diet as people age?
Diet quality usually goes down, right?
In what way?
We're usually having more processed foods, sugars, but then we're also decreasing the amount of animal products, meats, essentially.
Sad but true.
I see this a lot too with, as people age, maybe you go to the doctor's yearly checkup and they see, oh, your cholesterol's a little bit high. Let's decrease the amount of eggs and beef and all of that you're eating. And then it's a triple effect again.
Yes. So I would argue fundamental to this aging process, fundamental to muscle loss is diet. And nobody really talks about it much. But studies have pretty consistently shown that diet quality goes down with age. The amount of protein goes down, but the percentage of protein that comes from animal sources goes down also. So like you said, processed. People are eating less animal sources of protein as they age. And I don't know why that is, or if it's socioeconomic, or if it's the culture of, hey, you're getting old, you need to think more about health. And the perception is, hey, animal products are bad.
I think there's a lot of compounding factors to that all over. But just in general, it's just seeing that, we're just increasing the processed packaged foods over time in our consumption as people age.
So I want to bring something up, maybe off topic.
I love it.
So, and it has to do with muscle and myths. So my wife, Julia, recently had labs drawn, and she had a provider tell her, look, hey, your kidneys are in trouble, a little bit of trouble. Your creatinine is a little elevated. And really sort of scared her a bit. The idea that, hey, you got to eat, she was told actually, eat fewer animal sources of protein. Your kidneys are suffering, your creatinine's going up. Well, the more muscle a person has, at least directionally, the higher their creatinine. So bodybuilders, buff, monster bodybuilders, their creatinine levels in the blood are pretty high. Creatinine is sort of a breakdown product of muscle. It's related to creatine. And anyway, muscles use a lot of it. So the more muscle a person has, generally the higher their creatinine is going to be in their blood. But creatinine, the level in the blood, is also used as a metric for kidney function. So anyway, that raised the alarm for Julia. Well, she works out very consistently. She's fit. She's got muscle. Very fit. She recently had a percent body analysis, body composition analysis, and she's got a low body percent fat, high muscle mass. So what I told her is, look, no, your kidneys are fine. It's just that you have muscle. Therefore, you have a higher than normal creatinine. So, there are several studies that have looked at diet as it relates to muscle mass and serum creatinine and muscle strength. And one in particular I wanted to bring up, it was comparing these metrics or things in omnivores, people who eat all kinds of food, but including meat, versus vegans. Okay, turns out same age, same body mass index, gender, and everything. They're corrected for all the other major variables. And what they found is people who eat meat have more muscle. They also found that people who eat meat have higher creatinine. Again, that makes sense.
Makes sense.
Breakdown product of muscle. But they also looked at strength, grip strength specifically. And they noted a difference. The people who eat meat have more muscle mass, higher creatinines, but they are stronger.
And that makes sense. And I think that's a good thing to bring up too regarding, labs sometimes, is I think we have to look at a big picture when it comes to your labs, and just not just focusing on one number if it's high or low. So just going back to that idea, if you're eating a clean, animal products, diet. These things are okay.
You hesitate a little bit. I do too sometimes.
Sometimes I get nervous. I'm like, oh my gosh, I'm telling people the opposite.
You're
I know.
going to be attacked. It's unhealthy. How dare you say that?
Yeah, but it's true.
And I think that's one thing we're getting at is, look, it's the narrative, the myths. They're affecting us. Life expectancy is going down. Obesity is going up. Diabetes is going up. And there's a reason for all of it. Yeah, as I age, my diet is based on animal protein, meat, eggs, cheese. It's the best source of protein. And this has been shown over and over again that animal protein, animal amino acids are absorbed at a much higher rate than those from plants. And those essential amino acids, especially leucine. So leucine, for those who don't know, is an amino acid. It's essential. We cannot make leucine in our bodies. And leucine is the primary trigger for an enzyme system called mTOR, mechanistic target of rapamycin. Anyway, it's sort of a nutrient sensor. And when that complex or system is turned on, one of the things that generally happens is synthesis of muscle. Well, leucine, where do you find leucine? I printed off a study looking at all sources of leucine in our diet. It's all animal.
You can't get essential amino acids anywhere else besides animal
pretty
products.
Much. It's pretty tough too.
Yeah.
So muscle mass, it's related to longevity very clearly. So strength, very clearly related to longevity.
And over time, as diet quality decreases, that's why these muscle mass, muscle strength goes down.
Right. People don't eat animal products as much as they age. And I think activity is a factor.
Yeah.
But they develop insulin resistance, eating frequently, and the body's ability to build muscle and maintain it goes down. It's not an inevitable result of aging. I don't think it is. I think a summary is warranted. 4 things. 4 things I want to do in my life to live longer, but really to build and maintain muscle mass, to remain insulin sensitive, and to be metabolically flexible. In other words, I want my body to have the capacity to pull fat from storage and to burn it in a healthy way. 4 things to do consistently to that end. Fasting. Fasting is critical. If I want to slow the aging process, these are 4 things I want to do. I want to fast regularly. So I don't eat generally until about 12:30 every day, and about every quarter, every 3 months, I'll do a 3-day fast. 2 is exercise. There's cardio, there's resistance. If I had to choose, which I don't have to choose, but I do, resistance. Sleep.
Yes, that's a big one.
Yep, it's huge. And eat animals.
I love that. I love the last one. Eat animals.
Yes. We're built for it. We function best when our nutrition, and I hate to say fuel, another myth, okay?
Yes. No, I agree with you.
You know where I'm going?
Yes, I know where you're going.
What is it? What's the other myth?
What is it? Food is fuel.
Okay. Yeah. It's better than, okay. The other myth is that protein.
Is a fuel.
Yeah. That we use protein as fuel.
That could be a whole other podcast.
I know. But the idea is that, you eat so many calories and that your body will readily burn the protein that you eat, burn it as fuel. And your body is so smart. Again, in the context of someone who's healthy from a metabolic standpoint, they have metabolic flexibility. Their body's not going to just run off and burn amino acids or proteins.
Right.
It's a synthetic substance.
We're more elegant.
Yeah. So anyway, 4 things: fasting, exercise, strength training, sleep, and eat animals.
I love it. If we do those 4 things, we'll live long, happy lives.
I think so. So, anything else?
I think that covered most of it.
All right. Well, thank you for joining us. Please subscribe to the channel. For those watching on YouTube, thank you for being here. Super important. It's all about human potential. Thank you for joining us. We'll see you next time.
Bye. Thank you.